global object, and it has two things underneath it. One is meta, or meta. The meta stuff is usually returns back errors and things like that. We're just going to skip it. We're not even going to look at it throughout the rest of the tutorial. It's really good for returning errors that may or may not happen. But since we're not really going to handle any errors today, we're just going to skip it. And then the second part here is data. Anything that is in between the curly brackets is another object, and it has keys in it, so keys and values. For example, meta is a key, and the value here is an empty object. Org ID here is a key, and the value is actually this integer, this 9660. When you see the square brackets, it means there's a list. There's a number of things underneath it. That's pretty much all you need to know about JSON. That's literally everything. So it's really good. We can see all the information we kind of want in here is in here. If we can search in here too. So if we search for something called netix land set, this shows us all the public fabrics that we are on, that AS32934 is on. And here is pretty much everything we need to bring up to actually configure a peer. All the information's here, right? So I have the ASN number that, if we happen to use a different ASN at a certain location, it's there. I also have the IP addresses, the actual peer IP addresses across that fabric. That's pretty much all I need, right? I got the name of the IX, so we can use that for descriptions and stuff. So we pretty much got everything we need here. So let's actually let's see if we can actually do this in code really quick. So I'm going to bring up Adam here. Adam is just a standard text editor. We're going to be programming in Python. I'm going to use specifically Python 3, but nothing what I'm doing here is specific to Python 3. You can use Python 2 if you want to, but it's the latest and greatest, right? Let's use it. So I'm going to go ahead and create a new file in this folder that I have. And I'm going to call it peeringbuddy.py. And before we start, I'm going to use a couple libraries that to help us out here. So the first one I'm going to use is I'm going to install. So if I do pip is kind of a Python library installer. It will automatically go out to the internet and download stuff for you. On my machine, I use pip3. To download for Python 3, and regular pip downloads for Python 2. So they are two separate library repositories for each one. So you got to make sure that if you're using Python 3, use pip3. If you're using regular Python, pip works as well. So I'm going to install something called requests. Requests is just a really nice way of dealing with HTTP clients. So we're actually going to act like an HTTP client, like a web browser inside of our script. That's going to go out to PeeringDB and download stuff and bring it back down in. There is a built-in library in the Python standard library, so it's shipped with Python, called URLlib and URLlib2. They also provide an HTTP client. It's just a little bit harder to work with. Request just makes it a little bit nicer, and we'll get into that. It makes everything like one line of code. So. So I should probably already have this installed, and I do. But if you don't have this installed, this will actually go out, install all the dependencies, and get it ready for you. So that's all you really need to do. So now that we got requests, let's go ahead and use it. So the first thing I'm going to do is put a shebang up the top here. Shebangs are a way to tell your shell, go execute this using a particular interpreter. In this case, it's Python 3. So I'm going to user bin env Python 3. So this says go find Python 3 somewhere on my file system and then execute the remaining of the code inside Python 3. You can put Python 2 up here, just Python, and that will run on Python 2. And let's import the request library. So this says go ahead and use the request library, and now it's named requests inside my script here. The other thing I'm going to do is I'm going to say we're going to create a main function. So function we define with this def keyword. So we define a function, and I'm going to put all my code underneath here. But In Python, main does not get executed automatically, like in some other languages. We actually have to tell it to execute main. So we can do something as simple as this. This says, with the brackets here, it says go execute main. But if I import this file from, if I want to treat this as a library as well as treat it as like the entrance, you know, the executable to start my script, I don't want to execute main if I'm treating this as a library. So there's a neat little trick. You don't really have to understand this, but you'll see this in pretty much any Python code, where we actually do a very special if name. So this under name is a special variable that Python automatically fills out, depending on how that file is executed, I guess. And it will be set to under main if we're executing this file directly. So we won't spend too much time on that, but you'll see this everywhere. It's pretty much best practices to say, okay, if name equals main, then execute my main function. So with that out of the way, also, before I go any further, if you have any questions, raise your hand, scream, come up, slap me, do something, get my attention. We'll make this as interactive as possible. So if I'm going too fast or you're like, what the hell is that? Just let me know, okay? Okay? You guys awake? All right, all right. All right, now that we got the request library, request library allows us to do a bunch of stuff. Every time I start coding, I always either search Stack Overflow, search Google, or bring up the documentation or whatever I'm working on. There is no shame in that. Real programmers use all these resources all the time. I'm not a real programmer, but real programmers use this stuff all the time. So I usually just like look up the library that I want and then type in the language into Google and go, okay, tell me what's going on here. So I almost always have a browser tab open. And I kind of want to show you like the nitty gritty of coding here, which is you're going to be looking at documentation pretty much the entire time, or just copying and pasting from somebody else that's doing something similar. There's no shame in that. That's why we do these things. It's why we have open source, right? So right here on the main page, it pretty much says, okay, there's this request.get, and it returns back this this response that they've named R, and then we can get a bunch of stuff from it, like right here on the first page, pretty much everything that we want, right? Let's just do that. So request.get, we want that URL, so let's grab that URL from Postman here. So we'll just use the exact same URL we've been using, and we will paste that in here. We don't need any authentication, so we'll just leave that blank, and that returns back an R. And if we look back at the documentation again, it says we can do r.text or this r.json. Holy cow, so request actually will parse the JSON for us and give us back what looks to be a Python dictionary so that we can interact with it directly in Python. This is exactly what we want. So this just saved us a whole bunch of time from trying to load up the JSON libraries and parse it ourselves. So, let's just print. So print is a way to just print out to the screen. Let's just print r.json, and that is a function, so we got to call it with the brackets here. Okay, let's save that, and let's run it. So I have that file that we created here in a directory called NANOG 70, and I can either run this by typing in Python 3 peeringbuddy.py, and this will go out and execute it. And it's we're on a lot of public exchanges, so the file's kind of big, and the Wi-Fi is a little slow. So this is the exact same information we got back from the browser. It looks really bad. You know, we're back to squishing everything together to be efficient, but it's the exact same information. Now, if I wanted to execute this more like a program, and I want to just type in peeringbuddy.py, it's going to say permission denied, and that's because we don't have the executable bits on it. So if we chmod that, 755 says, actually, let's just do +x. So what this does is it says add the executable bit to this to say we can execute it directly. And now if we run that, it's going to read that first line. Bash is my shell is going to read that first line and say, okay, this is a Python program. I'll just pipe the rest of the document into the Python program. So now we have a real app, right? Like we created code. Cool. Let's do something about cleaning this up a little bit. So for debugging purposes, there's something called prettyprint or pprint. Pprint will format dictionaries for us and make them look all nice, just like Postman did for us. So let's call pprint.pprint. I know we're stuttering here. Pprint over and over again. But this will actually format the dictionary output for that. So let's save that and let's run that. Great. We're actually getting some caching now. You can tell because it's a lot faster. And we now have a nicely formatted JSON document that's returned back to us. It's not actually JSON. It's actually Python dictionaries, which is very similar to what we saw in the JSON, but it's available to us in Python. So let's actually demonstrate that. So let's say we actually want to print off the name here. So we know that instead of printing everything that comes back from JSON, let's actually store that as a variable called data. So data equals our JSON. And if we go back to our Postman, we can kind of follow the hierarchy here that everything's under data, and we know everything underneath that is a list because of that square bracket there. So the way we can access dictionaries in Python is with these square brackets. So we know data is a dictionary. We take these square brackets and say, okay, data, and then we have to quote this. And as soon as we quote this, this says, go grab this data section from the output. So we're skipping over meta. We're just saying, just grab me the data section. But we know that's a list. To access lists, list members are always indexed by numerics, by integers. So here, I actually just want the first one because there's only one. Everything, like a Junos router, I guess, everything's zero numbered. I personally really like zero numbered stuff, but so we know this is the zero numbered. So this should give us back ditches the meta and ditches the list of data that's in there, and just will return back what's in there, what's inside the actual data object here. And then we want to actually grab name. Because let's just see if we can print back just the name from this entire big list of data. So again, because we know this is a dictionary because it has keys and values in it, we'll access it the exact same way. So we'll quote that and put name in there. So now let's just print data, the first element, name. Yeah? All right. So now if we run this, it will go out, fetch that entire document, but instead of printing out the entire thing, we should get back just the pieces that we want. We'll print out just the pieces we want. And I'm going to take a sip of coffee while I'm waiting. And waiting. I was going to set up a local server for this, and I ended up not doing it because it was acting really fast at my house. But okay, there we go. So now when we run peering buddy, it went out and fetched that entire document, and we get back just the name. It's exactly what we want, right? And we know that everything else is in, everything else we need to set up Facebook as a peer on any IX is available to us right here. But we are feeding in this weird ID number. So 979 doesn't mean anything. Like, we don't know what 979 is. 979 is just a random ID that PeeringDB's database actually adds back in that's automatically created. So we don't want to look up anything via 979. We want to be able to give it an ASN number and actually get back a particular ASN. So let's modify this a little bit. So it's good practice to kind of separate your code out into different units, different functions that do particular things. This helps out in testing. This helps out with just like refactoring if I need to change a little bit of code. It's just good practice. We could put everything underneath main here, but let's actually create a new function called pdb-get-net. Or actually, let's call it query-net. So we created a new function just like we created for main, but this time we actually want to take in objects and return objects back. So we actually want to say, okay, let's take in an ASN. So this defines a variable that gets passed into the function called ASN. And let's just move everything that we have here And let's just, whoops, okay. PDB query, net. Just yank that, put that, okay. So now we just, we copied everything we had in main and we just moved it up. But we're still getting this 979. And we want to get this based off of the ASN number. I don't really know how to do that, but maybe the documentation has something on that. So let's go look at the documentation again. So if we go back to the API specs in here, this page is wonderful. It pretty much steps you through exactly what you need to do to interact with this REST API. Every single REST API will do this a little bit differently. So you need to find out, like, this is not universal for every REST API, but it is good for what we're doing here. So you can see that we can do a GET directly on an object. So this is API/object, not API/object/integer, not /979. And it has a bunch of optional URL parameters. So there's limit. We can, get back just 1 or get back 10 or get back 100. There's fields, which actually will turn back the exact items that we want. And then there's field name. And if we scroll down, we can actually see where if we pass in a name equals something, it will actually do a query for us versus just go grab a network information based off of the internal database ID. So we should be able to modify this a little bit so that we can put a question mark in here and put some information. Let's actually play around in Postman instead, because it allows us to kind of, without introducing bugs or fat fingering some code, we can easily just see if this is going to work for us. So the way to pass parameters into a HTTP GET is we hit a question mark at the end of the URL that we have. We put what we want. So we want ASN, and we say that's going to equal 32,934. And now if we hit send, fingers crossed. Fingers crossed. All right. So we got back the exact same thing. This is excellent. Now we can put any ASN in here. Anybody have an ASN I can use? 8075 is what I heard, right? All right. So if we put 8075 in here, got Microsoft. Okay, cool. Whoops. So now we can put any ASN in here and get the information back, even though the ID here is, again, some internal ID called 694. So, wait. If you notice something here, where's all my public fabrics? I only have just basic information in here. When I did the get on the ID for Facebook, I got everything, but now this is only showing me a little bit. What's going on here? Well, it turns out there's this depth field. So if you go in here and actually look, depth will actually find related objects. So anything that ends in like a set, it will go and actually fetch that related object for us and put it in. When we did the get on the internal database ID on that 979, it automatically grabbed all the relating objects for us. I think that's done for caching reasons. But because we're doing a query here, that information is not available to us unless we actually say it. So it says here in depth, the default is don't expand anything, or expand the first level to IDs, which is not what we want. Or we can say depth equals 2, and it will expand out everything. So let's give that a shot in Postman again. So to add a second variable into your HTTP GET request, you put an ampersand in between them. So we say ASN and depth equals 2. So now if we get that, hopefully we get back, there we go. We got back all that information we had before. So that's what we want. Let's just copy this, and let's go down to our code again. So I'm just going to paste in exactly what we had before. Okay. Let's copy that again. Cool. All right. So now we can go get Microsoft's information, but we haven't really solved the problem of downloading from any ASN. So we need to actually replace this ASN number with the one that's passed in from the function call here. So to actually call this, let's just show that really quick. We do pdb query net, and then we would say like 8075. But we need to actually replace our URL call with that 8075. To do that, we can do something called string formatting. So if we put in this special bracket character in here, so open bracket, close bracket, it's pretty much a placeholder. We put that placeholder inside this string here. And then strings have functions on them, so we can call a function called format. And format takes in the items that we want to place into those placeholders. So we can just pass an ASN here, and it will take the ASN that's passed in here. So let me kind of jump through this. So it will create a new line here. We pass in 8075 from main. 8075 gets placed into this ASN variable, and then we're able to use that ASN variable in other places. So we put the ASN variable here, which gets replaced via string formatting. This bracket gets whatever this first element is replaced with it. So now we should have a URL that's now dynamic. The other thing that we needed to do, instead of printing from this, we actually want to return back information. So let's actually return data, and because we know we want to just get just the first element of data back, just like we did before, let's return just that. And in fact, we're now just using data once here, so let's just call this r.json. Cool. Okay, so now we created a new function. It will go out and fetch any ASN that we want to, and it'll return back just the data information. So let's test that out. So this function call now returns something back with this return keyword here. So we can say data equals this. It will return back the information, whatever is returned back from here, and it will now be in data. So now let's pretty print that data. And actually, yeah, let's pretty print that data. So if we run that now, we should get back a nicely formatted dictionary of just the data section for Microsoft, and we do. Excellent. Okay, so let's go back to what now that we got that done, let's go back to what we were trying to do, right? We want to create router config. So we need to know, what is it, ASN, IPv4 address, IPv6 address, and maybe like the IX name. So let's just see if we can print those out to the screen. So the first thing we want to do is we want the actual name of the ASN that we're dealing with. So we're going to use string formatting again here. So I'm going to create a whole bunch of print statements. I'm going to say name, colon, and then I'll create that placeholder again, dot format. This is going to be data name, right? So this is pretty much exactly what we had before, but now we're doing string formatting so that it'll look nice. And let's create a couple more here. So we want ASN, IPv4, and IPv6. We'll line these all up so they're all nice. Now ASN, you could have, there's some certain organizations that have the ASN that they're known by, as well as a different ASN used for actual peering, sometimes acquisitions or whatever. So we actually want the ASN that's used on that fabric, not necessarily the ASN that we searched for them by, if that makes sense. And IPv4 and IPv6. So if we go back to our Postman here, we actually have a bunch of IPv4 and IPv6 addresses, and they're based off of what fabric they're actually connected to. So really quick, we'll scroll up. Everything's underneath this NetIX LAN set. And then, again, it has that square bracket there, so there's a big list underneath it. So what we want to do is we want to say, for every single LAN, let's print out this information. So we want to do similar similar code, but have it repeated for every single one of those IX LANs that we're on. So to do that, we can do a for loop. And a for loop is just a way to say, all right, create a block of code, and then for some sort of iteration, do this thing over and over again. So we're going to say for network, or for let's say for LAN, and we say in, what was it, data slash net ix land set. We know that's a list. So we can say anything that's a list. We can say go through every single object of that list and place that object in a variable called lan. And then we want to print all this stuff out. So if you haven't seen by now, Python requires indentation to kind of show where blocks are at. So indentation here says this is this function. Same thing for loops here. So we say for every lan, right, in data, or in net ix lan set, for every single lan, repeat this exact same thing. So when it gets to the bottom, it's going to go, okay, I'm done with that one. It's going to go fetch the next one, and it's going to print out all the stuff, and then it's going to keep going until there's no more. I'm going to add one more thing in here, which is an empty print statement. All that does is it puts a new line so that not everything is squished together. So now we should get name, ASN, IPv4, IPv6 for every single net ix lan for Microsoft. So let's save that, and let's cross our fingers. While this is running, any questions so far? Is it good? All right. Uh-oh. You guys probably saw this way before I did. You're going, Brandon, you're a moron. This is I just copy and pasted some stuff, but we actually don't want data here. We want to take LAN, right? And then let's see what's in one of these LANs here. So we want IP adder 4, IP adder 6, and ASN. So let's put ASN. And again, we're using this LAN variable up here. IP adder 4, IP adder 6, and this is also for LAN. Okay, so that should be a little bit better now, instead of printing off the exact same variable 4 times. While that is running, just clean this up a little bit. Okay, great. So now we're actually getting back, we're printing back the exact same name. We got the ASN for Microsoft happens just to be the exact same ASN for every single peer, which is great. And then we get IPv4 and IPv6 addressing. So we've pretty much got everything we want here. But now this is not router config. So we need to figure out how to turn this into router config. So what we could do is we could do a bunch of print statements and do string formatting, and that we can generate router config that way. Or there is another way of doing this. There's a library called Jinja2. So again, if we just tether our stuff to our web browsers, and we search for Jinja2 Python, it's a templating engine that allows you to create kind of like a kind of a master template that's easy to write for outputting router config or web pages or anything really you want, emails. It's got a lot of ways of creating loops and creating if statements inside of your template itself. So you can separate your code from your template, or your code from your router config. So it doesn't have to be linked in. This will come in really handy if we want to have multi-vendor support. If we want to output iOS XR as well as like a Junos config, for example. We can do that because if we have different templates, but they refer to the exact same variables, we can easily just replace one with the other. So just like we did before, let's install pip3, install Jinja2. I already have it installed. Okay, we're good. So let's import now Jinja2 into here. And again, we're just going to look at some of the example documentation on here. So let's click on documentation, close you. And there's basics, so just API basics. Pretty much has how we want to load this up. Documentation here is great, but there's a lot of it. So let's use a little bit of knowledge that we've gained before to skip some of that. So first of all, what we need to do is we need to create a template. So let's create a new variable, and this is a global variable. It's up at the top, not inside of a function. And we're going to call it template. And I'm going to do something where we create these 3 quotes in a row here. What that says is that anything in between these 3 quotes is part of the string. If I were to use single quotes are only allowed on one line. So if I do this and try to run this, it will fail. So we need those 3 quotes there. So let's create 3 quotes, and then let's create a really quick, let's create a Junos config here. And it's been a while since I've actually wrote code or config, so this might be wrong, but that's okay. We need a group, right? So let's call it peers. And then we have a neighbor statement. Is that right? Anybody? Am I doing this right? Yep. Okay, good. And the neighbor takes the IP address here, right? So we need to figure out what that IP address, we need a placeholder again, just like we did in string formatting. But Jinja does it a little bit different. It uses 2 brackets, which is good for us because we're using brackets everywhere else in this config. So string formatting might get a little confused with that. Luckily, Jinja just requires 2 brackets. So in here, we can actually say, okay, we want the IP adder 4, and then underneath that, we want a description of name, ASN, whoops, name, ASN, and then let's do the IX name. And then finally we need remote AS is ASN. All right, so that's kind of the framework of our template now. So we're just saying, okay, just like we did before, there's placeholders in here. But the problem is I'm not handling IPv6 here. So what I can do is I can copy this entire thing. The other thing is, I don't know if Microsoft has any of these. We can have multiple routers on the same IX, right? So there's going to be maybe 2 peers that we need, or 4 peers, or 8 peers, depending on how many routers or how many connections there actually is in that IX. So we actually want to do kind of do a for loop like we did before. So inside group peers here, I actually want to say I can create a for loop. Now in Jinja actually allows us to put for loops just like we did inside Python directly inside the template, which are actually really kind of cool. And the way that we do that is with these with brackets with % signs next to them. And the format is pretty much exactly like we had before. So we say for LAN in, I'm just going to say LANs right now. We'll go to find what gets into this template later. And then I have to say, because there's no indentation here, I actually have to say end4. So here's where we stop the loop, get the next object, and then loop through it again. So similar to where we had just indentation before. So, but now each one of these needs to actually be clarified with a LAN. So we're going to call this net.name, LAN.asn, LAN.name, and LAN.asn again. And where I'm getting these variables from is LAN is what I'm calling the IX LAN set variable, right? And if we look at one of the net IX LAN sets in Postman, that's where I'm copying these so we don't have to do any work. So I'm taking name, IP adder 4, IP adder 6, and ASN from here. The other thing we need to do is we just need to replicate this entire block. I'm going to get lazy and just replicate the entire thing for IPv6. So we're going to go through each one of the LANs and create a neighbor statement for IPv4 and IPv6. Good?
Do you generally put your v6 in a different BGP group, or do you mix them?
Okay. We typically put our IPv6 in a different group. I'm not going to do that here, but if you want that in your config, the cool thing about this is the template can fit whatever you want, right? You can change the group up here. You just have to modify just the template, not the code, to have it work any way you want. So if you have a group IPv6, we would just move this one level down, right? And then we can create groups peers v6, and we can create a new group here called just peers v4. Oh, and I got these backwards. And we get exactly what you want. So without really changing any code, just changing the template, we're able to do exactly what you state. And this is, I think how most of our config is done. Okay, now that we have that, we need to fill this out somehow. So we need to create a new template. So let's create a template. And have we imported Jinja? Yes, we have. So we imported Jinja2 as Jinja2. So we refer to it as Jinja2, and we just create a new template, and we pass in template. Now, got a bug here. I called what comes out of this template, but what I'm also passing in is template. This will actually work, but it's going to get confusing because I'm trying to use the same variable twice. So I'm just going to call this one T instead of a full template. And then T has I think it's called render. Yep. So once we create a template, we just call .render on it, and then we give it the variables that we want. Pretty straightforward. So T.render, we're going to pass in the data, and we're going to call that net. So net equals data. And then I'm actually going to kind of do a shorthand here and just say lands equals data net ix land set. So this will pass into our template, it will pass in a variable called net and a variable called lands, which is what we used up here, right? So here's lands, and then we're using net.name here into our template, and then we're rendering it. That render statement actually spits back out the rendered template, right? So all the values filled in is what that spits out. So let's say that equals output. Let's just say out equals that. And then let's get rid of this. And let's say print out. Right. Nope, don't need install. Okay. Uh-oh. No module name Jinja2. Live demos, man. It's is it capital J? No. It is for pip though.
Oh, really?
I already have it. Cool. This was working perfectly fine last time.
Python 3 because the shebang called Python.
Oh, I was showing you guys that. Yeah, so that's it was using Python 2 and not Python 3. So proof that this works just fine in Python 2 if you install all your dependencies. Because we've been running this in Python 2 the entire time. So let's do this in Python 3 now. And with any luck, we should get back all of Microsoft's peering information. And we do, and it's formatted in a router config. This is exactly what we wanted, right? So now we can go paste this into a router. But we don't want every single IX that Microsoft's on, because that doesn't make any sense, because our routers are going to be in specific IXs. So we want to limit this to one IX. So this is why I did the lands variable here. So I actually want to say, let's create I want to create a new list of lands, but this land is going to be filtered to just the IX that I want. So I'm going to create a new lands list here. So I'm just going to create it empty. So this creates a brand new variable called lands that's just an empty list. And then I'm going to say for every single LAN in data net ix land set. So I want to say if it's in a particular LAN, then I want to put it into this list up here. If it's not, I just want to continue. I just don't want to do anything. So what I'm going to do is select a particular LAN. So let's go find a LAN first. So let's go back to just regular peering DB. And let's choose a LAN to get the ID from it. So I actually just want 6 Seattle because we're Bellevue here. So there's a good chance that Microsoft's on it, I'm hoping. And instead of, because there's no like ASN, well there is ASNs for a lot of the IXs out there, but it's not going to give us the particular LAN. What I really want to do is just say I want to get a particular, I want some sort of identification to bring back a 6. So we can do a search, present this list back to the user saying, here's everything that has 6 in it. enter the number next to it. Like that's all going to take a whole bunch of time. So we're just going to take a shortcut right now and actually see that the ID here is 13. So we're going to look for all lands that have an IX ID of 13. So again, if we look at our postman here, IX ID is one of the fields that's inside net IX land set. So we can just say, okay, let's just look for all IX IDs that that are 13. So we're going to put an if statement in here. If statements are pretty much just saying a way to fork code, saying like, well, if this condition is met, then do something. If not, you can do something else. So we're going to say if land land IX ID, we're going to say equals 13. Then let's take lands, let's append it with the land that I just had. So we're going through every single land that comes back to us from peering DB. For every single one of those, we're just saying, okay, is this land IX ID 13? If yes, we place it into this variable. That's pretty much it. And so when we're done, lands should be populated with just those that are on 6. So the only other thing we need to change here, instead of returning back everything into our template, we want to just put in our new variable called lands. All right, so now if we run this, it's still going to go out. It's going to grab everything, but we get just those that are on 6. So this is our script. Now we can run this everywhere, and no longer my fat fingering router configs. They're exactly what's coming from peering DB. And this is exactly what we do at Facebook. If you want to peer with us, you better have a peering DB entry, because we are going to just scrape it and generate our configs for us. Because nobody has time for for manually entering in configs. So there's a couple things you might be looking at here, and we got a little bit of time left. So we hard coded in Microsoft's ASN, and we hard coded in 6. So we don't want to edit the script every time we want to run it. We want to be able to dynamically, from the command line, say ASN is 32.934 and the IX is 13. Right now that doesn't exist. So inside the standard library for Python, there's something called argparse. Argparse is an argument parser, so it reads in those arguments at the end of your command line and allows you to kind of do some, we'll parse it for you and give it to you in variables you can use in Python. So we can import argparse here. And then in our main, we can say, create a new parser. So we do my parser equals argparse dot argument parser. And we could put help and information in there, but we're just going to leave it blank for now. And so that gives us a new object called parser. We can say add argument onto this, and then we can give different stuff. If you look at the documentation for this, there's a whole bunch you can do with this. It is actually a really, really cool library if you're not familiar with it. And it's in the standard library, so that's great. But we want one called ASN. We know that its type is going to be an integer. So we're not going to accept anybody putting in like Microsoft in there. We actually want them to put an integer. So this locks it down, saying if you do put Microsoft in there, argparse will shut it down. And we can add help messages in here as well. I'm just going to leave the help messages empty. And we want one called IXID as well. So dash IXID. That's also an integer. And then we call parser dot parseargs. So we created a new parser. We added some stuff into it. And then parser.parseargs will go out, look at our command line, and compare it to the arguments that we added here, ASN and IXID. And if those are there, then it will return those back. And we're going to put that into a variable called args. So really quick, just to test this, I'm going to put print args.asn, which is how argparse actually represents it, is through this dot notation. And all this is in the documentation. We're just kind of skipping over the documentation for time here. And then args.ixid. And then I'm going to do one more thing here. I'm actually just going to return. And this is just a quick little dirty trick that says, okay, I want you to just run this top portion of code. And if I hit this return here, it'll automatically stop executing in the code below it. So it allows us to like not hit peering DB while we're testing out the arg parser section. So now, oh, this may or may not work. Okay, need to save that. So now if we rerun this, we're printing out just those two things and it's returning right away. Like we said before, if we put in like Microsoft here, it comes back saying like that's not an integer. Perfect. But we also have this problem that if we don't pass in anything, it actually gives us back this none. What's none? I can't look up router configs based off of none. So I'm just going to add one more thing in here. Let's put required equals true. So that's saying that if you don't have this, it's gonna fail. So now if we run this, told you this is why I'm not allowed to make router configs. Cool. So now it actually says that those arguments are required. So now we just have to plumb these in, right? It's pretty simple. So we get rid of our debug print statements in here. This becomes args.asn, and then down here it becomes args.ixid. Holy crap! I think we got it. Let's give this a shot. 32.934, and then ixid. It's gonna be 13. So if we run this, we should get back the config for Facebook on 6. And there we go. So we get back the config. I can go copy and paste this directly in there, and I know there's not going to be any fat fingers in it. So what do you think? Pretty cool? Any questions? Any questions? Yes? Okay, the question was, does PeeringDB have the networks that are associated to a particular org? No. The only thing it really does have that I know of, and I could be wrong here, is it does, if we go to, like, let's go to Facebook's page again. Come on. What it does have in here is the number of prefixes. So you can do a prefix limit, which is better than nothing. I think there's like RadDB and some other places out there that will actually have that information if you wanted to create filters and stuff. Good question. Anybody else? What would be next here? What would you guys like to see next in the script? Like what would, if you're going to run this in your org, how can you make it better? How can we make this better?
I would put a way of creating a manifest where I have my sites mapped to my devices, so I can put in a pop name that automatically pulls out the routers that are there associated with the IX lookup. And
yes. So pretty much the recommendation there was, okay, now we have router config. What router do I apply it to, right? And I could have 2 routers at this location, or 4 or whatever. I want to make sure that I apply these to the right routers versus just pushing them out randomly. So somehow creating a database or some sort of way of associating, okay, this IX has these routers in it. We can do that using a dictionary. We could use a SQL database if you guys have that in your orgs. There's a lot of different ways of handling that, but that's, again, it's exactly what we do at Facebook. It was, we have, all these routers are part of this IX. So when we actually generate config, instead of printing them off to the screen like we're doing here, we're writing them out to files that have the router name in them. And then we can use a different utility to go push everything to those routers, or do it directly from the script. We could have this script push directly to routers. Sounds scary? It's not. It's perfectly fine. Like seriously, like once you, there's kind of a general way of like as you're scripting. Like when you're first getting your feet wet, you do what we do here. We print it out to the screen so that a human could go look at the output and go like, okay, yep, that's exactly, yep, okay, that's good. That won't blow up the router. Okay, we're good. And then you start doing this so many times that you get bored of looking at it and you're like, well, of course I know it's right. Every time I check it, it's right. So then you go to the next step. It's like, you know what? I know it's right because I've tested it so many times. I've looked at it so many times. You go into pushing. So you actually have this manually go out and push it to the router, but maybe it doesn't commit it, right? Maybe it just puts it into the router, and then you go, okay, do a commit check. Okay, everything. Okay, we're not going to blow anything up. We're good. So you do a compare, right? You compare the what's out there with what you have, and you're like, okay, this is good. This is good. And you do that until you get bored of that because it's always the same outcome. And then you say, okay, just go commit it. Just go do it. And we pretty much take this exact same approach through any script that we're creating. We kind of go through this like baby steps into like, okay, the script is good. Like I don't need to babysit it anymore. We know it's good. The only time we need to babysit it is when we make any changes. So there's kind of a natural progression, I think, for scripting that kind of like gets your feet wet, make sure that like you're not going to blow up your network, and then you kind of go on. Cool. Yes, yeah. So you could actually write either something on the router or something that runs after this that goes, hey, what's changed? I expected only maybe 16 lines of changes in this config. There's 100. Like maybe I deleted a group somewhere on accident. Maybe I overwrote a group. I did a override instead of a merge, right? So yes, you could write something like that, or you can have it maybe submit to a review system. You create a review system where a human goes, oh, yep, that's fine. Hits yes on it, and that gets pushed out. All right, it's now 11:02. I think we're gonna have the microphone go around. So if you got a hack, it's 10:02 in Denver. It's 11:02. Is what I meant to say, of course. So if you have a hack, we'll have you announce it now, and then any other announcements. So. Thank you, everybody.
Thanks, Brendan. So hi, welcome everybody to NANOG 70 Hackathon. Most of you have already been here for at least an hour or more, but welcome anyway. So thanks for the tutorial. So kind of what we want to do now, Sean and I are just going to kind of give a couple logistical welcome to the hack. Here's some resources. Here's what we're going to do. We'll go through that, and then if everybody who has kind of put an idea in the in that shared pad, maybe just kind of come up, give like a 10-second speech of what it is. We'll throw the pad up there. We can just go through the list to try to get the ideas going. We want to try to put groups together. I think there's like 50 people here, maybe more than, maybe 60 people. I think 80 signed up. So I mean, group size, we probably want to try to have, I don't know, 10, 12, 15 groups, something like that. So try to make groups of 3, 4, 5, 6, whatever, something like that. The tables hold 6 each. So we're going to kind of do that. So let me just kind of, I guess, go through these. Sean's kind of running away, but that's all right. Oh, okay. I guess we don't have slides to even show, so there's nothing to go through yet. So has everybody seen the pad? Or, I mean, put your hand up if you don't know what I'm talking about. Okay, cool. So there was an email that kind of went out to, I guess, the Hackathon group. We'll try to put the link up here. It's just a shared pad to put ideas. If you don't know it and you have an idea, just come up and pitch it over the mic. That's fine as well. There's also a Slack channel, which should also have gone out. If you registered for the hack, you should have an invite for that. Feel free to use Slack to communicate within the room if you need. If you want to create private rooms or anything like that, you need help, just come grab one of us. While we're waiting for this kind of AV thing, I don't know if anybody wants to kind of start with an idea to kind of pitch, just so we're not wasting time. Anybody? Yeah, come. We have a volunteer. Thanks, Jill. Just before she gets here, there's also a few Facebook people around here. I think there's like 5, 6, 8 of us or something around. So if you need any help, just grab one of us as well. So.
Thanks, DJ. Hi, everybody. From my question, you can figure out which idea I have. The idea or problem I want to solve is to manually update. So not to manually update the filters that we get for the prefixes that we get from the customers in internet exchange side or just a normal internet hosting side. This is a big administrative burden. You rely on your ops team to go there and update stuff manually. Customer rings up, why it's not working? And it's in the database. It's like, it's not working because it hasn't manually updated yet. So it would be good to grab that data from some sort of database that's available from RIPE, for ARIN, for whichever regional registry, and obviously a safe way update the devices for the prefix lists or any filters that you have. So that's my idea. Thank you.
Cool. Thanks. Any other ideas they want to kind of pitch here? It looks like we're not going to be able to get slides, so we're just going to have a good old time here and just talk. So great. Introduce.
Hi, I'm Colin. I'll be working on a little Python script that just reads maintenance notifications from an email folder over IMAP and is going to post them to to a Google Calendar, and then if I have time, it's also going to send an email if it detects conflicting maintenance notifications. I don't have much to do with that, but if you're interested in working on it, I'm always happy to have more people.
Highly recommend talking to Eric. Yes.
Hi. This is perfect timing. I'm Eric. Colin, definitely come find you. I'm working on a general project to standardize the format of maintenance notifications so they can be machine parsed. We've done a bunch of work on this today during the hackathon. I want to work on extending the Python libraries that we already have. There's an interest in that, expanding the test coverage for that. Also, I'd like to start working on an implementation of the standard in Go so that we have 2 languages implemented. That's part of the requirements for getting an RFC in place.
Awesome. Thanks. More ideas? I know there is more than 3 on the pad, so just come right up. If you want to line up to pitch them so it goes faster, that'd be even better.
Hi guys, I'm Akshat. So I've been actually working on an OpenBMP controller that sort of works off the Kafka bus that OpenBMP pushes out to. And one of the goals there was to effectively try and get the RIB completely out of the BGP processes that are being dealt with on the router. So the adjacency in RIB that you guys would know is effectively what we're working on the controller side, so that we can build our own RIBs for all of the routers and then push only the selected routes into each of the routers based on the API that the vendor exposes. So at this point, we're working with static routes, but there is some more that we want to be able to represent in beer and gear probably a couple of days, which is RIB APIs that we want to speak about. But at this point, it is effectively a controller, and we're going to hack more into creating Python-based route policies that you can apply to that RIB, as well as basic path selection that you would do at the controller side before pushing the routes downwards. So hopefully this helps address a lot of TCAM issues that you might have in case you have routers that are not really powerful enough. And also, frankly, just moving to a Pythonic version of route policies is probably far more useful than depending on a vendor to give you the particular structure for it. So yeah, Mike and I are currently going to work on it, but more folks are certainly welcome.
Hey guys, I'm Mahmoud, and I'm gonna try to go and work on a system that basically has all template dependencies. From there, they'll be mapped with the vendors themselves, and then actually make it so you can have a full system that not only updates the configuration for you on your devices from PeeringDB, but then also validates the state of the devices through SNMP and CLI scraping and things like that. And based on that, you'll be able to not only validate the configs on the device, but the actual state of the device. So the actual number of prefixes you're receiving, sending, whether they map, and accordingly continuously update with whatever's in PeeringDB as well.
All right, anybody else? There's a couple more on this pad. If it hasn't been explained, I can kind of just read them off. If anybody else, no, maybe, hands up. Cool. What else do we have in here? So we had something about, I don't know why this chat window is in my way. It's really annoying. Automated peering notice, we did that. So automated peering port testing and turnup. So I guess that's just kind of configuring them, testing IPs, notifying pass fail. I found one on ordered shutdown turnup of edge ports and Tor. So blink the lights on a rack so you can check for cabling. That might be useful if you're working with smart hands or somebody on the site. Maybe an easy tool for them to kind of verify where things are plugged in, that kind of stuff. Service policy checker. That one's kind of long to read. I'm not going to read the whole thing. It's all on the pad. Outage status notifications before hitting SLA. So it looks like it's going to be, scraping to see is my service available, notifying maybe peers if it's going to be down. And the last one, automated public viewing, we kind of have that one already from this tutorial. So I think that's most of the ideas, but that does not mean you have to work on one of those. So feel free to collaborate as a group, go find one of the people that presented. Maybe if you don't have an idea or group, you can either just wander around to people that are sitting at their table, or maybe just meet up outside, talk, whatever happens to need to be. If you need an idea, come find me or somebody else, and we can go from there. So Sean, if you want to.
Sure. Just a few more logistics. So TJ, do you want to talk about the diagram and the?
Yeah. Cool. So there's a couple, I think we have about 12 of these topologies available if you need to use some routing devices to play around with any of your ideas. Like this hack, like what Brandon was showing, you don't actually need routers to do what you're doing, but if you need them, we have about 12 of these. Essentially what you get is a kind of small two fabrics connected to, 3 kind of devices connected together there. We have Arista in the bottom and Juniper at the top. With this, there's some jump hosts you can use to program from. Also, all the management ports on all of these devices have public IPs, so you can interact with them from your laptop script. So if you need one of these, come find me. I can hand you out a small diagram and the IPs to connect into them. Chris, I'm not sure where he went. Oh, he's back there. In the NANOG 70 repo, he put together some base configs if you wanted to just kind of throw them together. It's in Jinja. Actually, you learned a little bit from Brandon, so it's kind of similar templates that he used. So you can use those as a base config to get started if you need. Otherwise, you can just do whatever you want with this topology. Just keep in mind, we have a limited number of them, so if you're not going to use it, try not to grab one. Cool.
Or share them.
Yeah, or share. Like if you only need to do Juniper part, you want to play with the Arista part. Like, I mean, you could probably have 2-3 different groups working in different areas of one of these topologies. So cool.
And something important, we only have those available today. So if we will be, one of the things we're going to do is at the end of the day, we'll select the top 3 hacks, and those hacks will be able to give a brief presentation, lightning talk type presentation during NANOG 70. We won't be able to have enough time to do demos, and this infrastructure will not be available after today. So you might want to get screenshots, grab any information, record things running. If you do plan to potentially present, you also want to obviously pull your code off and save it, and so you can use it later.
Yeah, they'll be available, I think, running till around 7 or 9 or something like that this evening. So cool. Do you want to go through this stuff?
I think we've covered most of this. So obviously the challenge here is peering automation. As Brandon suggested, that'll probably help you in the voting if you do hack on that, but we welcome that you hack on anything. Brandon has the information on the pods available if you want to hack on networking information, but we've gotten a lot of great suggestions about notification. You could hack on documentation, really whatever you want to do. The main thing we want you folks to do is to participate and get involved.
Yeah. So last couple of things. So at the end of the day, we're going to do a prototype form. I don't have the agenda in front of me. I think it's around 4:30 or 5. 5 o'clock. Cool. So what we're going to do at 5 o'clock, we'll live stream it again just so we have it kind of out there. But you have roughly 3 minutes to present, just so we can get through everybody. So the idea would be, just come up and talk about whatever. You don't need fancy slides. You don't need any of that. If you want to plug in your laptop, if you want to just talk about your idea, or share why your hack did or didn't work. That's always good for all of us to learn. Like, hey, I tried this idea. These are the blockers I ran into. But even sharing that information can help all of us grow and get better together. So that's a prototype form. You should have got a raffle ticket when you came in and registered. At the end of the day after the prototype form, we'll give away some prizes. So try not to lose that. There was also some pretty sweet stickers I recommend getting. They're pretty cool. So that's basically all I had there. So
Has everyone got on the Wi-Fi?
oh, good point. Like, is anybody having issues connecting to Wi-Fi, connecting to any of that kind of stuff? Does everybody have? This is the pad that we're reading from. If you want ideas.
Posted in Slack. So.
Yeah, and Slack is probably a good place to be communicating. If you're not on Slack, let me know. Come to me, and we'll make sure you get an invite. Anybody that registered should have got a Slack invite already. So, if not, just come find us. Yeah, I think that's mostly it. So, I mean, thanks a lot. If you need anything, come find me. Again, I have the pod information up here if you need it. Any troubles, any problems, come find myself, Sean, Chris, Brandon, Facebook people. There's a bunch of people around that can help. So,
and
thanks.
Feel free to do speed dating. Talk to people that presented hacks and see if it's of interest to you. And
Yeah, definitely. Like if one of the ideas you heard is something you want, just everybody that talked, put your hand up, and you'll know like where. In well, okay, nobody's doing it, but whatever. Just go find one of the people that was talking. It's a small room. You'll be able to find them. So cool. Thanks everybody. Enjoy the hack, and let me know if you need anything.